Welcome to qnawire.
Here we're going to write down the rate law for the following reaction mechanisms. For the first one, we're told that the second step is going to be the rate determining step. So the rate would be equal to K2 times the concentration of this species. Br minus. Okay. But since this is going to be an intermediary, as you can see over here, it is going to cancel out. What we want is also at what rate this guy is going to be produced. And from the step one, what we know is that the rate forward is going to be equal to K1 times the concentration of this compound, BR, times the concentration of R3N. The rate backwards would be equal to K to the minus 1, the concentration of HBr, Br minus, times the concentration of R3 N plus H. So at equilibrium, what we know is that both of the rates are going to be equal. So since the rates are equal, we can calculate the concentration of the species that we desire as K1 over K to the minus 1 times the concentration of Br times the concentration of R3N. Actually, let me put it down below because we're running out of space. So what we would get is that the concentration of HBr minus is going to be equal to this quantity on the right hand side. So with this, our rate equation is going to be equal to K2, K1 over K minus 1 times the concentration of Br over here, concentration of R3N over the concentration of R3 NH plus. And with that, it would be all for the first reaction. Now for the second reaction, the component forming steps are faster than the first step, so the rate determining step is going to be the first one. So in this case, the rate of the reaction is going to be equal to K1 times the concentration of this original product. Sorry, of this reagent. I'm going to label this reagent A directly just to get the result, and that would be all. Thank you very much, and have a good one.